Okay, what we're going to do in this recording is have a look at some of the mathematics behind LDA, linear discriminant analysis. And as long as we make some assumptions, usually about it being normally distributed, we can actually send up this function here, which I'm going to call the linear discriminant function. And what it does is it calculates this thing, which we've denoted as delta kx, and that is the posterior probability of an observation x being in group K. So what do I mean by posterior? Well, the idea is this. We start off with a prior belief. We sort of go, well, if I was just going to guess where it belongs, well, the probability is going to depend on how much in each group. So we've got this term here, this log pi k. The pi k here is the prior probability. It's the probability of being in that group before I get any data. And obviously, the easy thing to do is estimate that. Notice the little hat to indicate estimation is going to be the number of observations in group K over the total number of observations. And then what we do is we put all the data together and we update that to give us a posterior probability. What have we got in here? We've got our data, we've got the x's. You've got this sigma term here. Sigma to the -1 just means it's the inverse. This sigma is our variance covariance matrix. It's how much the data varies. It gives an idea of how it varies together and how it within itself. And the mu k is going to be the mean for the kth group. So quite a complicated little thing, but you can see that this whole thing is made up with some estimates. We already talked about our prior belief of being in each group, which is the number of observations over m. This is basically the mean for everyone in the ith group. And here is our variance covariance term. Complicated thing, but it's a matter of just putting these formulas into R and it will work it all out for you. So that's what we do. We can put all this together. It's a nice simple equation that you can do involving a lot of linear algebra you've seen already. And you'll get this number. Then how do we decide which group you belong in? Well, we can calculate for every observation the value of this function, this k, and then we will choose the group where this is largest. So just a sense of some of that linear algebra we're sort of thinking about is still there underneath the hood. Okay, that's all for now. Bye.